Hello students, welcome back to JJ's physics class. Today we will be doing some numericals based on velocity time graph. So what we are going to do is, we are going to describe the velocity time graph. We are also calculating acceleration from velocity time graph, also calculating the total distance traveled from the velocity time graph. In the last class, we have discussed about how we can interpret velocity time graph. We also know that what we can conclude from the interpretation of velocity time graph. The first one is the gradient of the line, which is equal to acceleration. Negative gradient indicating that deceleration. Flat section means that the object is moving with constant speed. And if you want to calculate the area under the curve, what you get? You get the total distance traveled or displacement of an object in a given interval of time. The question here is, the speed time graph shows a 50-second car journey. Describe the 50-second journey. So you can see here, time is along the x-axis, speed is along the y-axis. You can see that the car started from 0 meter per second at time t is equal to 0. It reached 15 meter per second. Then it traveled in a straight line. That means with a constant speed. Again it accelerates, then decelerates, final reaches to 0. First thing what we are supposed to do is, we have to split the graph like this. So if you get this kind of numericals for your examination, first you need to analyze the graph. So for that, it will be difficult for us to predict the nature of this graph. We are going to split the graph up into 4 portions. A is in the form of a triangle, B is in the form of a rectangle, C is in the form of a trapezium, and D again a triangle. Describe each part of the journey, ensuring to use the numerical values throughout. Section A, you can see that the car is accelerated from 0 and reach up to 15 meter per second. So the final velocity at this section A is 15 meter per second. You can describe the section A as, the car is accelerated from 0 to 15 meter per second over the first 10 seconds. Since the line is a straight line, you can also say that the acceleration is constant. When it comes to the part, here you can see that the line is flat, that indicating that this car speed is constant. That means the car speed does not change over next 10 seconds. You can also say that the car is moving at a constant speed, or the acceleration is 0. If velocity is constant, you can directly say that the acceleration is 0. For the next part of the journey, you can say that the car is accelerated up to 25 meter per second over the next 10 seconds journey. And section D or part D, you can say that it spends last 20 seconds to decelerating down to 0 meter per second. So this slope indicating that this is decelerating, or the object is moving with negative acceleration. Got it? Next, for the same graph question, you need to calculate which section of the graph has the greatest acceleration. Again, we are dividing this graph into 4 different parts. So what we are going to do is, we are going to calculate the slope of each part separately. Then we are just comparing the result. Then we know that which part has the greatest acceleration. And we also know that the gradient of the line which gives the acceleration, that is the important point. So we must find gradient of each section. So let us start with A. So section A, the acceleration between 0 to 10 seconds. So this is 10 seconds, and the initial velocity in this case is u is equal to 0, and it has the final velocity, what is that? 15 meter per second. So how to find out the gradient? It is nothing but the slope of this line. Final value minus the initial value divided by this part gives you what? Slope or the gradient. So final value is 15, initial value is 0, and again along the x-axis time is, so final value is 10 and the initial time is 0. If you calculate, you get it as 1.5 meter per second square. Let us denote this as 1. For part B or section B, you can say that here the velocity is constant. You can directly write it as, if velocity is constant, the acceleration will be 0. So this is the second part. For the third part, you can calculate the slope of this line. So how do we calculate? So we take the triangle here. Here the initial velocity is 15 meter per second, but here the final velocity is this value, that is 25 meter per second. So 25 meter per second minus 15 meter per second. What is the time axis value? So 30 minus 20. 30 minus 20. So 25 minus 15 will be 10. 30 minus 20 will be 10. So what you get? 1 meter per second square. So this is the third session. And for the last one, you know that you have to calculate again the gradient. The initial value becomes 25 meter per second. But the final velocity is touching the x-axis, that indicating that v is equal to 0 meter per second. So final value 0 minus 25 and time axis is this 50 minus 30. 50 minus 30. So what you get? You get a negative acceleration as minus 1.25 meter per second square. So when you compare, you know that section A has the largest acceleration or the maximum acceleration of 1.5 meter per second square.